We have laws of thermochemistry. There are basically two laws. The first law says that the amount of heat required to decompose a product into its elements is equal in magnitude but opposite in sign to the amount of heat energy given out when a compound is formed. What you're trying to mean, in case I'm having sodium chloride and I dissolve it in water and I get sodium ions and chloride ions, and that heat change is positive 776 kilojoules. It means, according to the law, that the heat change required to break sodium chloride into sodium ions and chloride ions, it will be the same heat value if now sodium ions and chloride ions were able to react backward reaction to give us sodium chloride solid, but now they are saying it is equal in magnitude, meaning the value remains the same, but the sign is going to change. If the forward reaction is positive, then the backward reaction is negative. For example, we can see that sodium ion plus chloride ion giving us sodium chloride solid, the enthalpy change is going to be negative 776, and to form the ions it was positive 776. So it means in thermochemistry, every time if in my calculation I'm required to reverse it, then I should just change the sign of that value. The second law, or the Hens's law of heat summation, says that the enthalpy change of a chemical reaction at constant temperature and pressure is the same irrespective of the number of stages, but will depend on the initial and the final stages of the reaction. What you're trying to mean, if I'm converting A to B and the heat change is A, any value A, may be positive 77 or negative 77, depending on the type of reaction. It will be the same if my A, I first convert it to C, as you can see here, then C I convert it to D, then D I convert it, then D I convert it to B. Now what you're trying to mean, a direct route, that is A to B, giving us enthalpy as A, it will be the same as summing up X plus Y plus Z. The standard enthalpy change of formation, which says that the enthalpy change that occurs when one mole of a substance is formed from its elements in their normal physical state at standard temperature and pressure. What we are trying to mean, in their normal physical state, in case it is carbon, it should be carbon in form of graphite, not diamond. Then in case it is oxygen, it will be in form of oxygen O2, not oxygen ozone O3. So it means we shall always strictly form 1 mole of the product, then we shall balance the reactants the way we want. And the values of enthalpy change of formation are always negative, signifying the highly stable product being obtained. But you should put in mind that enthalpy of formation, we cannot determine it directly, but we can get it indirectly using Born-Haber cycle. Then enthalpy changes for elements at standard condition are 0, because elements are always found in pure physical state. Yet we are saying enthalpy change of formation, enthalpy change that occurs when 1 mole of a substance is formed from its elements. So if we have an element, so we don't know which elements we use to form an element, so to mean their enthalpies of formation in their pure physical state, they are 0. For example, oxygen, in this case it is 0. Now it means we are going to use other values to be able to calculate enthalpies of formation. For example, enthalpies of combustion. Calculate the enthalpy change of formation of carbon monoxide, given that the enthalpy change of combustion of carbon is negative 93 kilojoules per mole, and that of carbon monoxide combustion is negative 286 kilojoules per mole. It means I'm looking for this equation when carbon is reacting with oxygen, giving us carbon monoxide. This is the enthalpy of formation we are looking for. Now, if I'm to write enthalpy of combustion of carbon, when 1 mole of carbon is burning completely, it gives us carbon dioxide. When 1 mole of carbon monoxide is burning, it gives us carbon dioxide. Now it means I have equation this and this. So if I reverse the equation where I'm having carbon monoxide, because I'm supposed to use these two equations to come up with this equation I'm looking for. If I reverse this equation where I'm having carbon monoxide, so as to get carbon dioxide as a reactant, giving us carbon monoxide plus a half oxygen, and the sign which was negative, now here it becomes a positive enthalpy, because we said if I reverse it becomes positive. Now this one, carbon is required as a reactant, we are just going to add them. So when I reverse, you can see that this carbon dioxide will be able to cancel out with this carbon dioxide, and this half oxygen, we shall remain with a half oxygen in this case, and it's going to give us this equation where I'm having carbon plus a half oxygen, and enthalpy formation is negative 107, that is negative 3 trial. Capture the enthalpy change of formation of methane from the following thermochemical data. Enthalpy of combustion of carbon is given, that of hydrogen and that of methane. Solve it. Let's meet in the comment section. Answer is negative 75 kJ per mole.